We often imagine black holes as violent destroyers, but the beginning is calm. As you fall, gravity does not pull you apart, not yet. Space stretches gradually. Your feet feel a stronger pull than your head. A slow stretching begins, gentle at first, almost unnoticeable. Physicists call this tidal force. It is only later, deep inside, that the stretching becomes extreme. Before long then, you have already crossed the point of no return. Take a moment here. Let your breathing slow, because this journey is not about fear. It is about understanding one of the quietest, strangest places in the universe. Nothing you hear tonight is science fiction. Every idea comes from modern physics and what we truly know and what we honestly still do not. If you enjoy calm journeys like this, where science is explained gently, without noise or exaggeration, you may want to subscribe to this channel. These stories are made to be returned to. And if this video helps you relax or sparks curiosity, pressing like quietly supports more explorations like this. You can also share it with someone who enjoys falling asleep under the stars. Before we continue falling, let's slow down time. A black hole is not an empty hole waiting to swallow things. It is an object with mass, often millions or billions of times heavier than the sun. That mass bends spacetime so strongly that all paths lead inward, not because it wants to destroy, but because gravity is geometry. Space itself is curved. As you drift closer, nothing suddenly changes. There is no pulling wind, no shaking. From far away, the black hole looks dark because light cannot escape. But where you are, space still feels open. The stars remain behind you. Ahead of you, only darkness, not because something is hidden, but because no light can return from there. Somewhere ahead lies an invisible boundary. It has no surface, no sudden edge. This boundary is called the event horizon. Crossing it does not feel special. Your body does not react. But every future you could have had now points in only one direction. From your perspective, time continues normally. One thought follows another. But far away, for anyone watching, something strange is happening. Your motion slows. Your light stretches toward red. And eventually, you appear to freeze at the edge of the black hole. You never seem to fall in. Two versions of reality now exist, and both are true. You continue falling. There is no sense of speed, no rushing air, no vibration. In space, falling feels the same as floating. Gravity here does not pull like a hand. It reshapes the path that space and time allow you to follow. Near a large black hole, gravity changes slowly. This is why, at first, your body remains intact. There is no sudden force tearing you apart, only a gentle difference between how strongly gravity pulls on different parts of you. This difference is what creates tidal forces, and for now, they remain quiet. Imagine space like a fabric beneath you, not a solid surface, but a flexible one. As you fall, This fabric stretches very slowly. Your feet are drawn inward just a little more strongly than your head. You do not feel pain. You feel alignment, as if the universe is gently asking your body to point toward the center. Much later in the fall, this stretching becomes extreme. Physicists sometimes call this spaghettification, not as a joke, but as a description. Objects are stretched in one direction and compressed in another. But remember, this does not happen at the edge. It happens deeper inside, where tidal forces finally become overwhelming. From your point of view, this change takes time. Seconds still pass. Thoughts still form and fade. But for the universe outside, something very different is unfolding. Your signals, every photon you emit, are struggling to climb out of the curved space-time around you. As light travels up against gravity, it loses energy. Its wavelength stretches. Blue becomes white. White becomes red. Red fades into infrared, until eventually your image disappears entirely from view. Not because you vanish, but because light itself can no longer escape from where you are. You have now crossed a boundary that cannot be marked on any map. There was no moment you could point to and say, "This is where it happened." Yet the universe knows. Every possible future you can experience now leads inward. Forward in time has become deeper into the black hole, and the fall continues. You may wonder, at this point in the fall, whether turning around would make a difference. But inside a black hole, the idea of back quietly disappears. Every possible path you could take, forward, sideways, or even what once felt like upward, now curves inward. This is not because something is chasing you or pulling you by force. It is because space-time itself has changed its shape. Inside the event horizon, moving forward no longer means moving away. It means continuing deeper into the black hole. Outside the black hole, escape is a matter of speed. If you move fast enough, you can leave. But here, speed is no longer the issue. Even light, the fastest thing the universe allows, cannot find a path outward. Every ray of light, no matter which direction it tries to travel, is carried inward by the curvature of space-time. To escape now would require moving not faster than light, but backward in time. And that, according to everything we know, is not possible. Here, the fall becomes difficult to imagine. Inside the event horizon, space and time exchange roles. Outside, time moves forward no matter what you do. Inside, moving inward becomes just as unavoidable as time itself. You do not fall inward because you choose to. You fall inward for the same reason you move from one second to the next. The center of the black hole now lies in your future, not as a place, but as a moment you cannot avoid. And yet, even now, the fall does not feel violent. There is still no sound, no shaking, only the steady continuation of experience. This is why black holes are so difficult to truly understand. From the inside, nothing announces that reality is breaking. The universe remains quiet right up to the point where our equations begin to fail. Ahead of you lies a region physics cannot yet describe. But before we reach it, there is still more to understand about the fall itself. At this point in your journey, a natural question begins to form. How long does this fall last? From the outside universe, the answer seems to be forever. But from where you are, time continues to pass in a familiar way. Seconds still follow seconds. There is no endless waiting. In fact, if the black hole is massive enough, the entire fall, from the moment you cross the event horizon to the moment you reach the center, can take only minutes, or at most, hours of your own time. Not all black holes are the same. Smaller black holes have stronger tidal forces near their edges. In those, the stretching begins early and violently. But supermassive black holes, the kind that sit quietly at the centers of galaxies, behave very differently. Their immense size spreads gravity out. The curvature of space-time changes more gently at the horizon. This is why in these enormous objects, you could cross the edge without realizing that anything special has happened at all. As the fall continues, the stretching of space becomes more pronounced. Atoms are held together by forces far stronger than gravity. For a long time, those forces win, but deeper inside, tidal forces grow without limit. Molecules begin to separate. Atomic structures can no longer maintain their familiar shapes. This is not destruction in the dramatic sense. It is the quiet undoing of structure, driven by geometry alone. Eventually, according to our current theories, all paths lead to the singularity, a region where density becomes infinite and space-time curvature has no upper bound. But here, physics begins to speak in uncertain language. Our equations can take us close, but not all the way. What truly happens at the center remains unknown, not because it is hidden, but because our understanding has not yet reached that far. When physicists speak about the center of a black hole, they often use a single word, singularity. But this word does not describe a place in the usual sense. It is not a tiny object hidden at the center, waiting to be reached. A singularity is a signal. It tells us that the equations we are using have reached their limit. According to general relativity, density increases without bound. Curvature becomes infinite. But infinite here does not necessarily mean something physically real. It means our description is no longer complete. For most of this journey, Einstein's theory of gravity has guided us well. It explains the fall, it explains the horizon, it explains why time and space behave so strangely. But near the center, gravity becomes so strong that quantum effects can no longer be ignored. And here, our two great theories, general relativity and quantum mechanics, no longer agree. They speak different languages, and neither can finish the story alone. You might wonder whether anything meaningful can continue beyond this point. Matter, as we understand it, cannot survive unchanged. The structures that define it, atoms, particles, identities lose their meaning in such extreme conditions. Yet some physicists believe that information itself may never truly disappear, not destroyed, but transformed in ways we do not yet understand. This idea is still being explored, and for now, it remains an open question, not a settled answer. This is a natural place to pause the fall, not because the journey is over, but because we are approaching the edge of knowledge itself. Everything so far has followed known physics, careful observation, tested theory, honest uncertainty. What comes next will still be grounded in science, but it will also require imagination, patience, and humility. So for a moment, allow the universe to remain quiet. The fall has not stopped. We are simply listening more carefully now. As the fall continues, a quiet question begins to surface. When something enters a black hole, is it truly gone? Or does some trace of it remain, hidden in a form we cannot yet see? In physics, this idea is called information. Information is not memory or consciousness. It is simply the complete description of a system, the details that make one state different from another. According to quantum physics, information is never destroyed. It may change its form, spread out, or become incredibly difficult to reconstruct, but it does not vanish. Black holes challenge this idea. From the outside, anything that falls in seems to disappear completely. Mass, charge, and rotation are all that remain visible. Everything else appears lost. This creates a tension between our theories. Gravity suggests a clean erasure. Quantum physics insists on preservation. This conflict is not a flaw in nature. It is a sign that our understanding is still incomplete.
In the 1970s, physicist Stephen Hawking discovered something unexpected. Black holes are not perfectly black. At their edges, quantum effects allow a faint release of energy. This is known as Hawking radiation. It is incredibly weak, far too faint to observe directly from distant black holes. But over immense spans of time, this radiation slowly carries energy away. The black hole loses mass. Very gradually, it shrinks. For stellar or supermassive black holes, this process takes far longer than the current age of the universe. Trillions upon trillions of years. Time spans so large that human intuition simply lets go. If information escapes at all, it would do so stretched thin across unimaginable time. Whether this truly preserves everything that fell inside is still being studied. For now, the black hole keeps its secrets, and you continue falling, carried forward not by force, but by the quiet structure of space-time itself. As you continue inward, your own sense of time remains steady. Moments follow moments. Thought follows thought. But far beyond the black hole, the universe does not wait. Stars continue to burn through their nuclear fuel. Some grow unstable. Some collapse. Some fade quietly into darkness. Entire civilizations, if they exist, rise and fall without ever seeing the end of your descent. Over millions of years, galaxies drift.
Their shapes stretch and change under the influence of gravity. Spiral arms unwind. Star clusters scatter. Collisions occur, not as explosions, but as long, graceful mergers that take place over ages of time. While you fall, the night sky itself becomes unfamiliar to any distant observer. As time continues, fewer new stars are born. Gas clouds thin. The universe cools. Light becomes rarer. Space grows darker. Not suddenly, but gradually, as if the universe is learning how to rest. From the outside, the black hole remains a quiet memory of once crowded skies.
And still, from where you are, none of this feels rushed. The fall does not speed up. The universe does not announce its aging. There is only continuity, a steady movement forward through an unfamiliar direction that time itself now follows. You are not watching the universe end. You are simply passing through one quiet path it allows.
As unimaginable ages pass outside, the universe slowly changes character. There are fewer surprises now. The raw materials for new stars are nearly gone. Clouds of gas that once glowed with promise have already collapsed or dispersed, or been locked away inside long-dead stars. Creation becomes rare. What remains is evolution without novelty, slow rearrangements of what already exists. While you continue falling, the universe begins to repeat itself. In this distant future, black holes become some of the last large structures left. Galaxies have thinned, stars have dimmed, but black holes endure. They drift through space like quiet anchors, holding on to matter long after light has grown scarce. Around them, little happens quickly. Everything slows, not because time itself changes, but because there is so little left to transform. From the outside, your black hole is no longer remarkable. It is simply part of the background of an aging universe. Eventually, even motion begins to lose its meaning. Temperatures approach near uniform cold. Energy differences flatten out. Without gradients, nothing pushes change forward. This is sometimes called the heat death of the universe. Not an explosion, not a collapse, just a quiet evening out of everything. In this future, events still happen, but so slowly that calling them events feels unnecessary. And yet, inside the black hole, the fall continues. Your experience does not stretch across billions of years. It unfolds smoothly, moment by moment, untouched by the vast aging of the universe beyond. Two timelines coexist, one where almost nothing ever happens again, and one where movement toward the center remains inevitable. Both are real, both are quiet, and neither rushes you. Far in the future, even black holes do not remain forever. They lose energy quietly, patiently, through Hawking radiation. There is no flash, no dramatic collapse, just a slow release of warmth into cold space. For supermassive black holes, this process lasts longer than stars, longer than galaxies, longer than almost anything else we know. Trillions upon trillions upon trillions of years pass. Time stretches so far that numbers stop helping. Only duration remains. As the final stages approach, the black hole becomes small. Its temperature rises. The radiation grows stronger, but only at the very end. Somewhere in the far future, the last black hole releases its final photons, not as a message, not as a signal, just as energy returning to space. After that moment, there are no stars, no glowing cores, only particles drifting through an almost perfect cold. In this era, there may be nothing left to observe anything. No eyes, no instruments, no memory of what once was. Events still occur in a technical sense, but without observers, they leave no trace. The universe does not mind. It does not require an audience. It simply continues quietly existing in its most even, settled form. And still, your journey inside the black hole remains unchanged. While the universe outside reaches its calmest state, your experience does not stretch across eternity. It unfolds gently, one moment at a time. You are not racing against the end of everything. You are simply moving along a path space-time allows, unaware of the silence that has settled everywhere else. At this depth, the idea of the future begins to feel different. Outside the black hole, the future once meant new stars, new light, new change. But here, the future is not a sequence of possibilities. It is a single direction. Forward does not mean choice anymore. It means continuation. Just as time carries you from one second to the next without asking permission, the geometry of space-time now carries you inward. This is not imprisonment. It is structure, a rule written into the shape of reality itself. We often rely on words to make sense of experience. Distance, speed, location. But inside a black hole, these words grow less useful. Not because something dramatic has happened, but because the assumptions behind them no longer apply. You are not traveling through space toward a destination. You are unfolding along space-time itself. The closer you move to the center, the less meaning there is in describing where you are, only that you continue. At the center, our equations point towards something they cannot describe. The singularity is not a prediction of what is. It is a question mark placed by mathematics. It tells us that space-time, as we understand it, cannot be extended further. Whether reality itself ends there or continues in a form we do not yet grasp remains unknown. This uncertainty is not a failure of science. It is an invitation to deeper understanding. And so, instead of forcing an ending, we allow the story to soften. There is no final image you need to hold, no conclusion you need to reach. The universe does not always resolve itself into answers. Sometimes it offers only continuity, a gentle movement from one moment into the next. And here, inside the deepest fall imaginable. That is enough. By now, there is nothing left you need to understand. Understanding was useful earlier, when questions mattered, when direction mattered, when names mattered. Here, understanding can rest. The universe is no longer asking for explanations. It is simply continuing in the only way it knows how. You do not need to picture where you are. You do not need to imagine what comes next. The fall is no longer something happening to you. It is something happening as you. Each moment follows the previous one without effort, without resistance, just as sleep does.
Somewhere far behind, though behind is no longer the right word, there was a beginning. A time when black holes seemed mysterious, powerful, dramatic. But you now know their quiet truth. The beginning is calm, the middle is calm, and even the deepest regions do not announce themselves with violence. Space stretches gradually. Tidal forces begin gently. Nothing demands your attention. Nothing pulls you awake. The fall continues exactly as it did before, smooth, silent, uninterrupted. If you listen closely, there is a rhythm here. Not a sound, a pacing, a steady unfolding of one moment into the next. Space-time itself breathes this way. Expansion, pause, continuation. There is no faster way forward. There is no slower way back. Just this constant, gentle movement that does not require your awareness. You are free to drift with it, free to let thoughts thin out, stretch, and dissolve into background silence. At this depth, stories stop progressing. There is no next chapter waiting to be revealed, no climax, no resolution. The universe does not move toward conclusions. It moves toward balance. And balance feels very much like rest. You may notice that your attention drifts in and out. That is expected. You may forget parts of what you hear. That is allowed. The fall does not require memory. It only requires continuation. And if at any point your awareness returns, gently, without urgency, you may notice something familiar. The calm beginning, the gentle stretching of space, the quiet truth that nothing sudden ever happens. The fall does not restart. It never stopped. You are simply aware of it again. And so, without an ending, without a signal, without a change in tone, the journey continues exactly as it always has.